a straight line along the y-axis. At the next step, I'll just go to 1. At I equals 1, it's going to be, my x point is going to be 0, 1, and my y point is going to be 9, 0. So this is basically just defining lines by 2 points, one on the x-axis, one on the y-axis. So now I'm going to just tell it plot x versus y, and then end my loop. And I don't want to suppress the plot, otherwise it's not going to show me anything. So now I can just go up to run all, and it will run each step of this script. So you can see here, this is basically 100 straight lines that make the illusion of a smooth curve. So what would you say the equation of this curve might be? What does that equation look like? Just from all the way back in Calc 1 or when you were graphing stuff in algebra. So, I mean, to me it looks kind of like a 1 over x function. So, what would you say if I told you that it was actually a parabolic function? It doesn't look like a parabola, does it?
Yeah.
But this is where the change of base comes into play. So parabolas usually would have this curve centered along the y-axis, which would be coming out here at a 1, 1 angle, or 1, 1 vector. So if I want to create now a new script that will show this with a change of base. So first of all, I need my basis matrix. So like I said, one of those vectors is going to be 1, 1, and then since I want to shift it in this direction with the y-axis at 1, 1, I'm going to need my x-axis to be along okay, wait, how did I do this? I did this the other way around. So if I assume that I'm in a non-standard basis with that as my y-axis, then my current x-axis is 1, 1, and my current y-axis is 1, minus 1. So that will become my non-standard basis. I don't need to show that. So now I have my x and y creation, but now I want to create a new set of vectors instead of the x and y here. I'm going to create a new matrix that is the inverse of that b times my x and my y. So this is going to hold the new basis points of those previously established effectively vectors. And now instead of plotting x and y, I'm going to plot these c values. And in this case, C is only going to have it's only going to have 2 rows, so I just call each row and then every spot within that row using the 1 parentheses and the 2 parentheses. So that can go down. So now when I run this, it's going to take this previous figure and translate it so that it's now centered along a vertical axis. What is your problem?
Do you need to put a comma with where the b is, the -1 and 1?
Oh, so I do. Oh, that shouldn't have. Let's see, is that it? No? This is exactly the same thing I did on my computer and it worked just fine. So why are you being fussy?
Oh, it's wrong.
Okay, well, since this is being fussy, I will just show it on the system that I was able to run it on. And I'll try and figure out why this was being annoying later. So, yeah, if I run this here, I get that I translate the figure from the previous, where this side was the x-axis, this side was the y-axis. Now the y-axis runs straight up the middle. So that's just a visual demonstration of this is the kind of thing you can do with change of basis. This is a very simple example. A lot of higher math involves this type of transformation and changing things from one type of coordinates or one setup into another. I wish Mo was here because he had a great story about this, but some work that he was doing involved looking at a very looking at a series of pretty standardized waves coming in at a very broken and jagged surface. And to model the surface would be effectively impossible. The tiny imperfections is just too chaotic of a system to mathematically model. But what you can do is you can perform a transformation, grab the wrong one again, take it into a system where the waves are the chaotic and the surface is just a straight line. Seems like it didn't make an improvement, except that the particular style of wave has already been mathematically modeled. So you can run your calculations over in this setup where everything's already been done for you basically, get your answers, and then transform it back into your initial setup. So we talked last week about using this same kind of thing for cryptography. You can use it for these kinds of graphical analysis. You can use it for numerical analysis. A lot of math is just figuring out how can I make this thing that I can't work with or that is hard to work with look like something that's much easier to work with, solve it there, and then translate it back into whatever it originally was. So again, that's going to be basically the whole second half of a linear algebra class and pretty much the second half of a differential equations class once you hit stuff like Laplace transforms. So that's really about it for today. Like I said, next time we're going to be using some of these just general techniques of taking a mathematical description, turning it into a function to do what I mentioned is called the Gram-Schmidt orthonormalization process. So that non-standard basis that I gave you that didn't have all your directional vectors orthogonal, it would take that and give you a basis that does have orthogonal vectors, all of which have a length of 1, which again is what makes this so very nice. And then we're going to use that to solve a problem involving finding the best fit line of a series of data points from an experiment. So, yeah, what's up?
Oh, I was going to say, for the live editor, what we're just doing, like, in order for it to work, instead of having C equals Z backslash X comma Y, it's supposed to be X semicolon Y, and then it'll run.
Yeah.
Okay, and does it get you the same thing?
Yeah, it looks the same as up there.
Ah. And so it does, thank you. So I'm not entirely sure, because in mine it doesn't have that semicolon and it still ran fine. So I'll have to, again, this is why when I did this I didn't document it, so I have no idea why it works on my laptop and not here, but good catch on that, thank you. So, yeah, that's it for today. I can address your issue you had with that function. If anyone else has questions, I'll be here for a bit longer. And you're welcome to just play around for a bit if you want.